Hi there, my fabulous chemistry students. Video notes number 3. Today we're going to look at saturated versus unsaturated solutions. Again, 2 new vocabulary terms and a new table in our reference tables we need to know how to use. So can we predict how much of something will dissolve in a solution now that we know what solutes dissolve in solvents? Well, yes, we actually can use a graph in our reference tables to help us predict how much will dissolve, how much solute will dissolve. So first definitions. Unsaturated sounds basically just like it is, right? Like the word stands, unsaturated. I can get more solute to dissolve in a given amount of solvent. Saturated is a solution that contains the maximum amount of solute that can dissolve, okay? We would say a saturated in solution terms is at equilibrium. When I try to remember the difference between saturated and unsaturated, I think of a sponge. A sponge that has a little bit of water on it is not saturated. But once I get so much water onto that sponge that it can't take in any more water, it would be saturated. So the same thing with solutions, except for the sponge in that case would be the liquid. Okay, and so here is a pictogram. Let's walk our way through this. If I take the 30 grams of salt and I put it into exactly 100 milliliters of water, it all dissolves. So if it all dissolves, we'll say that this is unsaturated. And it looks a little bit better in your notes than it does on this board. Unfortunately, when I made it big, it didn't come out looking too pretty. Okay. So the saturated solution is down here. If I put the 40 grams of salt into that same amount of water and I stir it all up and a little bit here doesn't end up dissolving, that means that this water is holding as much salt as it possibly can. And the reason I know is because look, here's a little bit left over that didn't dissolve. It precipitated out, or actually never actually did dissolve. So I don't know if we'd call that a precipitate necessarily. But that solid at the bottom tells us that it's saturated. Now a supersaturated solution, very rare, very rare. If we can make one this year, maybe we will try. This is when more solute is able to dissolve than normally would happen. Okay, so this usually requires an increase in the temperature or the pressure, and it is very, very unstable. Basically, if every supersaturated solution I've seen, they do take a very long time to make. It takes a lot of product to get more in there than should dissolve. And if you either tap the side of the flask or add one crystal of this of what the solute was, a whole bunch will fall out of solution. So at least we'll have some videos to show you what this looks like on YouTube. Okay. All right. So some situations. If you have an unsaturated solution and you add crystals, what will you observe? Well, if the crystals dissolved or disappear, the rate of dissolving is greater than the rate of precipitation. If you have a supersaturated solution and you add crystals, you will observe all crystals precipitate out. So the stuff will start coming out of solution until it's just at saturation point. Okay. The rate of dissolving is less than the rate of precipitation. If you have a saturated solution and you add crystals, they will just sink to the bottom. Sorry about the bells. The rate of dissolving equals the rate of precipitate, so we could say that they were in equilibrium. We will start to learn what that word means in the next unit or two. This is table G. Show you what that is real quick. This is what it looks like. This is in our reference tables. It looks kind of complicated, but we will go through it quickly and let you so you can understand how to use it. Okay? Better yet, how to use it. Table G shows us the number of grams of substance that can dissolve in specifically 100 grams of water. Now that's important because a lot of the questions are going to be like, well, what if we use 50 grams of water? Well, then you got to take that number of grams that can be dissolved and divide it by 2. Because I did it with the water, I divided it by 2. I did 50 grams of water. And it's grams of water, not milliliters of water. So we got to pay attention to all this stuff, okay? Each curve represents the maximum amount of that particular substance that can be dissolved at any given temperature. We have a lab where you are going to make your own curve to better understand this. All lines show an increase in solubility as temperature is increased. represents solids. The line for gases slope the opposite way because, as we'll learn, the colder it gets, the more gas I can get to dissolve. It's not hotter. It's opposite of solids. Okay. The intersection of grams in solute versus temperature falls. If I fall on the curve on that previous slide on table G, then I am saturated. If I am under the curve, then the solution is unsaturated. If I am above the curve, then the solution is supersaturated. Okay, take a minute for that. That's how we actually use it. You need to know this part backwards and forwards. It's going to feel a little, what do we say? It's a word I'm looking for. Come on, Mr. Milks. Anyways, it's going to get easier with practice. How's that sound? So here is a particular example. A and B is going to come up later, but I'm just going to use A and B to talk about it now. It actually has to do with a particular problem we have to do. It's going to be referring to NaNO3. See how that symbol points, the arrow points to that line? So that's the line we're looking at this time. So if I were A, I would be supersaturated. If I was B, I would be unsaturated. My point would have to fall exactly on the line to be what we call saturated at that particular temperature and amount of solute. Okay? So that's basically how we read the chart. So how many grams of NaCl? Oh, we're going to have one more set of these bells. I very much apologize. How many grams of NaCl will dissolve in 100 grams of water at 90 degrees? So we got to find a few things. We got to find NaCl. Found it. So that's this line. Okay, and that's the only line we're going to be worried about for this problem. Then I got to find my 90 degrees. I'm going to read up, and it says I will be able to dissolve approximately 40. And I wrote all over this thing, so I can't see it real good, so let's erase. Oh, yeah, good. So it is right here on the line at 40, which is 40 grams. 40 grams of NaCl will dissolve into 100 grams of water. So the answer is 40. See how we did that? Not too hard. Let's do one or two more, and then we'll call it, and I'll let you finish the rest to get full credit for your homework. How many grams of KCl will dissolve in 50 grams of water? Now notice this is the water cut in half, and then the next problem is the water doubled. So that is we're going to have to take that into account, okay? So let's find KCl. And I'll even switch colors. KCl, oh, I found KCl, so that's this sloped line. One of the things that usually happens is we end up getting confused and picking the wrong line, so I want you to be very careful with this. Okay, now I got to go back. What temperature? 30 degrees Celsius, KCl. So 30 degrees, KCl is right about here. That is, I would say, about 35 grams, we'll call it. But the problem is, it says per 50 grams of water, not 100. So because 50 is half of 100, I have to take half of this 35. So I'm going to say 35 divided by 2 is going to equal, what, 17.5 grams. Okay. So now in this next one, we will double. Okay. So it says how many grams. Oh, so it's the same thing. So I thought it was, I found out it was 35 with 100 grams of water. So now instead of dividing by 2, I've doubled the amount of water. So now I need to multiply by 2, and that'll be 70 grams. Makes sense. If there's more water, I should be able to dissolve more stuff. Now, this is a piece that I'm going to make sure I let you do, but I'll give you a hint. It's in your notes which way the slope is going to go for a solid and which way the slope is going to go for a gas. So you go back in the notes and check that out, and then you'll be able to pick any two that match the criteria. Okay. And number 6 is a solution that is made up of 100 grams of water and 70 grams of KNO3 at 50 degrees saturated, unsaturated, or supersaturated. Why? Well, how about I help you with that one? Because that one looks like it's kind of complicated. So KNO3 at 50 degrees. 70 grams. KNO3, let's start with KNO3. I found it. KNO3 is right here. And it's set at 50 degrees. Follow it up 50 degrees till I hit KNO3. Okay, and it says 70 grams. So that is actually here, right? 70 grams at 50 degrees is there. If I'm KNO3, am I above the line, below the line, or on the line? If this is my spot, I'm below the line, so therefore I'm unsaturated. So the answer to this one is unsaturated because it falls below the line. Okay? Below the line is unsaturated. You finish these last few to get full credit for your homework. Now here's where things are going to get a little bit more involved, okay? And for a bunch of the notes after this. So first of all, we can differentiate now between saturated and unsaturated solutions. We can use table G to determine specifically, am I unsaturated, saturated, or supersaturated? That's what this whole notes was all about, okay? Now you can complete the practice packet, pages 5 through 7. When you're done with that, you go to Castle Learning. Quiz number 1, prep. Now this is going to be an open quiz where you'll get 2 tries at each answer, and it's technically not graded, okay? But you need to do it. You need to do it because, guess what? When you're done with that, you get to take the actual quiz, which is you don't get 2 tries. You don't see what the correct answer is. And this, hopefully, this pattern of doing things is going to help you not have to take as many retakes and not have to make me open them up to review so you can see what's going on, okay? It's already given to you in a review format with this quiz number 1 prep. So do the prep. That's going to prep you. You'll be able to pass the quiz in far few tries when you've done the prep first. So if you come to me with the quiz and I need to get another quiz done, and I'm going to ask you first, did you do the prep or not? Okay? So sorry this video took a little bit long, but we had to understand thoroughly how to use that graph, and we're all set. Good day and happy studying.